Hello students, in this video of chapter 3 class 9th physics, C part linear momentum and Newton's second law of motion we will discuss in detail. In linear momentum, that is the product of mass and velocity. Linear momentum is represented by small p, mass with small m, and the velocity with small v. It is a vector quantity. SI unit of linear momentum is kilogram meter per second and CGS unit is gram centimeter per second. Change in momentum. Change is represented by delta P. Delta means change and P is the product of mass and velocity. So there are two cases. One relation you have to learn, m is equal to m naught 1 minus v square upon c square root in denominator, where small m is the mass of the body when it is in motion, moves with v velocity. M naught is the relativistic mass. This is the mass of body at rest. V is the speed of the body with which it is moving. C is the speed of light. Case number 1, when the speed of body, that is v, is quite less than c, then m is equal to m naught 1 minus v square upon c square root in denominator. This particular part v square upon c square is very small, so 1 minus very small factor will remain 1 only, and m is equal to approximately this m naught, means mass remains constant. So delta p is equal to m, which is constant, that will take out, and delta will come only with the velocity. Case number 2, when v is quite large than c, or v is comparable to c. M is equal to m naught 1 minus v square upon c square root in denominator. V we can replace with c, so c square upon c square will be 1, 1 minus 1 0, and thing divided by 0 is infinity. So m is approaching to infinity, means m is not constant, it is varying. So delta p is equal to delta, which is change, will come for mass as well as for velocity. We can't take mass out of this delta, so delta will be common for mass and velocity. So this is very important expression. Next topic is rate of change of momentum. So first we will discuss change in momentum, that is final momentum minus initial momentum. Delta p, delta is for change, p is for momentum, so change in momentum is delta p. mv is final momentum, mass into final velocity, minus mass into initial velocity is initial momentum. Mass you can take common, then v minus u in parenthesis. A rate of change of momentum is equal to change in momentum divided by time. That is equal to m into v minus u, which represents change in momentum, divided by time. So v minus u, that is the change in velocity upon time, is acceleration. So we can write finally rate of change of momentum is equal to mass into acceleration. So rate of change of momentum is directly proportional to the force applied, and the change in momentum will take place in the direction of force applied. So that is according to second law, Newton's second law, force is equal to mass into acceleration. This is also very important expression. Now there are three possible graphs can be made on the basis of this expression. Now out of these three terms, when mass is constant, so mass, if it is constant, so acceleration will be directly proportional to force, means force if will increase, acceleration will ultimately increase. So it is directly proportional. This kind of proportionality graph will have. Second is when acceleration is constant, in that case mass is directly proportional to force, means more will be the mass, more force is required for the same acceleration. So it will also be a constant proportionality graph. When f is constant, then acceleration is inversely proportional to mass. From this you can see. Now inversely proportional graph will be like this: less mass, more acceleration for constant force, more mass, less acceleration for constant force. after this, a relationship between Newton and dyne. As you know, 1 Newton is equal to, this force is equal to mass into acceleration. So SI unit of force is Newton, mass kilogram, acceleration meter per second square. So 1 Newton can be defined as a force which is applied on 1 kilogram body and it start moving with an acceleration of 1 meter per second square. Kilogram we can write in terms of CGS unit 1000 gram, meter per second square as 100 centimeter per second square. 1000 into 100 will be 10 raised to power 5 gram centimeter per second square. This will be dyne. So 1 Newton is equal to 10 raised to power 5 dyne. The next topic is Newton's second law of motion in terms of rate of change of momentum. So this we know that delta P upon delta T is equal to mass into acceleration. And this also we know force is equal to mass into acceleration. Now compare 1 and 2. So force is equal to delta P upon delta T. Now this force is the external force which is equal to the rate of change of momentum. So force is equal to delta P upon delta T. Delta P we can write as delta mv upon delta T. Now if mass is constant, so that we can take out from delta. So m into delta V upon delta T. This delta V upon delta T is acceleration. So finally force is equal to mass into acceleration. Here is the statement which is very very important. Newton's second law of motion is the rate of change of momentum of a body is directly proportional to the force applied on it, and the change in momentum will take place in the direction of the force applied. Then examples of second law of motion in daily life. First one is while catching a ball, the cricketer withdraws his hands along with the ball. So in this case, F is equal to delta P upon delta T. As the ball is moving with certain initial velocity, finally when it is caught by the person, so he will lower down his hand. So by doing that, he is going to increase the time. When delta T will increase, means time of impact of ball with the hand will increase, denominator will be increased. It means force impact will decrease, effect of force will decrease. So by withdrawing his hand a little bit back, he will try to reduce the effect of force. Same case with the second example. Athletes often lands on sand or foam after taking a high jump. So the moment when he will strike with the floor which is covered with the sand or foam, so the time of collision of the person with the floor will increase. If floor time will increase, this denominator will increase, ultimately force effect will decrease. Same case, when glass vessel fall on a hard floor, it break, but they do not break when they are falling on the carpet or sand. So same case, when it is falling on the hard floor, delta will be decrease. Delta T if it will decrease, okay, delta T if it will decrease, so force effect will increase. In the denominator, if it will decrease, so force will increase. So with that, there are more chances for the glass vessel for the breakage. And if it will replaced with the carpet or sand, means directly it will not allow, it will allow to fall on carpet, delta T will increase and force effect will decrease. This very small part is left, that to obtain Newton's first law of motion from second law of motion. So as you know, force is equal to mass into acceleration. Now if F is 0, if this F is 0, mass into acceleration has to be 0. But mass is the one of the factor which will not become 0. It will remain or have certain value. So acceleration has to be 0. It means body, when it is not acted upon by an external force or does not change its state of rest or of motion, So this statement is of first law, but we started from the second law. So students, please see this video again and again to get the full clarity of the concept. Thank you very much.